Hello, in this lecture we will find the radius of the small circle. In the drawing we have a quarter circle and we know that chord CD equals to 2 units, OD equals to 3 units, angle BCD equals to 90 units, and inside the quarter circle we have a small circle and we want to find out the radius of this small circle. Okay, so first of all we will define the center of the small circle as point P. Then we will join points A and P together by a straight line. Actually, AP or PA is the radius of the small circle. I will mark it as R. And we also will join points B and P by a straight line. And we will define the touching point between line segment CB and the small circle as point X. Then we will join points P and X together by a straight line. Actually, PX is the radius of the small circle because it starts from the center of the small circle, that is to say from point P, and ends at point X, that is a point on the small circle itself. Therefore Px is the radius of the small circle. Okay, so we will define angle ABP as theta. This angle will be defined as theta, and we actually know that tangents theta equals to AP over AB. Okay, again, tangents theta equals to AP over AB. And we know that AP is the radius of the small circle, so I will write here, I will substitute AP by small r over AB. So if we multiply this equality by AB, we will get that R equals to AB times tangents theta. Okay, R equals to AB times tangents theta. So in order to find out the radius R of the small circle, we have to find the values of line segment AB and also the value of tangents theta. Okay, so first of all we will focus on two triangles. Triangle APB and triangle PBX. Actually, we will define that those two triangles can go end to each other First of all, we know that AP equals to PX equals to R. AP in triangle ABP equals to PX, and both those two line segments are equal to the radius of the small circle, so they are equal to each other. Okay, and we also know that PB is a common side, so PB equals to PB. Actually, side PB belongs to triangle APB, and side PB also belongs to triangle PBX. Therefore, side PB is a common side. It belongs to both triangles. And also AB equals to AB in triangle ABP equals to BX in triangle PBX. Again, AB equals to BX according to two tangents theorem. So those two sides are equal to each other according to two tangents theorem. Actually, two tangents theorem states that the lengths of two tangents from a common external point to the circle are equal. Okay, so I will read two tangents theorem again. Two tangents theorem states that the lengths of two tangents from a common external point to the circle are equal. Okay, actually, from point B we have two tangents, tangent AB and tangent BX. So those two tangents that are both from a common external point that is B are equal to each other. That is to say, AB equals to BX. So actually we proved that all the sides of triangle PBX are equal to all the sides of triangle ABP. Okay, so therefore triangle PBX congruent to triangle ABP according to side rule. So I will read again the things that I wrote. Triangle PBX congruent to triangle ABP according to side rule. So if you prove that all the sides of one triangle congruent to all the sides of another triangle, then those two triangles are congruent to each other according to side rule. Okay, so from the fact that triangle ABP congruent to triangle PBX, we can derive that angle ABP that is equal to theta equals to angle PBX. Those two angles are equal to each other, therefore angle PBX will be also equal to theta. Okay, so angle ABP equals to angle PBX, and both those two angles are equal to theta. Okay, so in the next step we will extend CB and OD until they intersect. Okay, so here I will extend line segment CB and then I will also extend line segment DO until those two line segments will intersect, and the intersection point of the two line segments will be defined as E. Okay, line segment CB, after we extended it, intersects with line segment DO after we extended it at point E. Okay, and actually angle ABC, angle ABC that equals to theta plus theta, actually equals to 2 theta. Angle ABC is equal to angle EBO, and both those two angles are equal to 2 theta. Again, angle ABC equals to angle EBD, and both those two angles are equal to 2 theta according to the rule that vertex angles are equal to each other. Okay, according to the rule that vertex angles are equal to each other. Again, angle ABC equals to angle EBO, and both those two angles are equal to each other because of the fact that those two angles are vertex angles. Therefore, according to the rule that vertex angles are equal to each other, they are equal to each other. Okay? And we actually have quarter. This is a quarter. Therefore, from the fact that we have here a quarter, we can derive from it that angle DOA is a right angle, that is to say it equals to 90 degrees, because of the fact that we have a quarter. Okay, so angle DOA is equal to 90 degrees. Okay, and we also know that ED is a straight line. ED is a straight line. Okay, and we have a rule that states that the sum of the angles on a straight line is equal to 180 degrees. I write it down. The sum of the angles on a straight line the sum of the angles on a straight line is equal to 180 degrees or 180 degrees. We will read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees. So, according to this rule, the sum of the angles on the straight line BE at point O must be equal to 180 degrees. So, this angle that is 90 degrees plus the size of angle EOA must be equal to 180 degrees according to the rule that I stated. So 90 degrees plus the size of angle EOA must be equal to 180 degrees. So we will subtract from this equality 90 degrees, and we will get that angle EOA equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle EOA is a right angle, that is to say it equals to 90 degrees. So actually, if we focus on triangle BOE, this triangle, so in triangle BOE, angle BEO, will be equal to 90 degrees minus 2 theta. Okay? Because of the fact that this angle is 2 theta, and we know that the sum of the angles in any triangle is equal to 180 degrees, and we know that triangle BOE is a right triangle, then angle EOB equals to 90 degrees. So the rest two angles, those two angles must be equal to, in total, to 180 degrees. That is to say, 2 theta plus angle 2 theta plus angle BEO must be equal to 180 degrees. Must be equal to 90 degrees, because angle BOE is already equal to 90 degrees, so the rest two angles must be equal to 90 degrees in order to complete the sum of the angles in this triangle to 180 degrees. So 2 theta plus angle BOE must be equal to 180 degrees to 90 degrees, and if we subtract 2 theta from this equality, we will get that angle BEO equals to 90 degrees minus 2 theta. Okay, so this angle BEO equals to 90 degrees minus 2 theta. Okay, so now we will focus on the big triangle, triangle CDE. We know that triangle CDE is a right triangle. Actually, the sum of the angles in any triangle, and especially in triangle CDE, must be equal to 180 degrees. So in triangle CDE, the sum of the angles must be equal to 180 degrees. So 90 degrees plus 90 degrees minus 2 theta plus the size of angle EDC, the size of this angle, must be equal to 180 degrees or 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Then in triangle ADC, 90 degrees plus 90 degrees minus 2 theta plus angle EDC equals to 180 degrees. So here we have 90 plus 90 is 180, so 180 will get cancelled with 180. So what is left here? Minus 2 theta plus angle EDC equals to 0. Minus 2 theta plus angle EDC equals to 0. Here we will add to this equality 2 theta, and we will get that angle EDC equals to 2 theta. Okay, angle EDC equals to 2 theta. So angle EDC, this angle equals to 2 theta. Okay. So actually triangle EDC is a right triangle. Therefore, we can implement the Pythagorean theorem in the right triangle EDC, that is to say, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Therefore, in triangle EDC, CD square plus CE square must be equal to DE square. Okay? In triangle EDC, according to the Pythagoras theorem, CD square plus CE square equals to DE square. But before we solve this equality, we know that angle ECD equals to 90 degrees, and actually angle ECD is a peripheral angle. Angle ECD is a peripheral angle and it is equal to 90 degrees. It is given us in the question that angle ECD equals to 90 degrees, but because of the fact that angle ECD is inside the quarter that was given to us, therefore angle ECD is a peripheral angle, and we know that this peripheral angle ECD equals to 90 degrees. Okay? And we have a rule that states any peripheral angle that equal to 90 degrees must rest on the diameter of the circle. Okay, so I will write the rule down. The rule states that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. So I will read the rule again. The rule states that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. So, and we know that angle ECD is a peripheral angle that equals to 90 degrees. So, according to the rule that I presented to you, this angle, the peripheral angle ECD rests on the diameter, therefore DE is the diameter. Okay? So, from the rule that I stated to you, we can derive that DE is the diameter of the quarter circle. Okay, so we know that the peripheral angle ECD rests on the diameter DE of the circle. Therefore, when you have a quarter circle, we know that this is a quarter circle. OD must be the radius. So I will call the radius of the quarter circle capital R. And we know that DE is the diameter of the quarter circle. Therefore, DE is diameter must be equal to 2R. So if DO equals to R, then OE must be also equal to R. And we know that R equals to 3, so OE equals to R, that equals to 3 units. Okay? OE equals to 3 units, that OE, so we can write down that DO equals to capital R and OE also equals to capital R, and both those two radiuses of the same of the quarter circle are equal to 3 units. Okay, so OD equals to R equals to 3 units, and OE also equals to capital R equals to 3 units. So okay. So in the next step we will create semicircle from this quarter circle. So we created semicircle from a quarter circle, and we know that OE equals to R, that equals to 3 units. So if we focus on the big triangle, the big right triangle, triangle CDE, in triangle CDE, because of the fact that it is a right triangle, we can implement the Pythagoras theorem in the right triangle CDE. That is to say, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And so it means that CD square plus CE square equals to DE square. And we know that DE equals to 3 plus 3, that is 6, so DE squared is 36. Again, according to the Pythagoras theorem, C D squared plus CE squared equals to DE squared, and DE squared is 36, plus, so it equals to CE squared, and we know that CD equals to 2, so CD squared is 4, 2 squared is 4, so we got that 4 plus CE squared equals to 36. We will subtract from 4 from this equality, and we will get that CE squared equals to 32. Okay? CE squared equals to 32. We will take a root out of this equality, and we will get that CE equals to root of 32, but 32 equals to 16 times 2, and the root of 16 is 4, so we will get that it equals to 4 times root 2. So we found out that CE equals to 4 times root 2. Okay, CE equals to 4 times root 2. Okay. In the next step, we will again focus on triangle CDE. We found out that CE equals to 4 times root 2. But we also know that in triangle CDE, the big triangle, tangents 2 theta, equals to CE over CD. Okay, very simple. Tangents in triangle CDE, tangents 2 theta equals to CE over CD. Again, tangents 2 theta equals to CE over CD. But we know that CE equals to 4 times root 2, and we know that CD equals to 2 units. So we can write here CD equals to 2. Yes? So, and CE equals to 4 times root 2 over CD, that equals to 2. Okay, so actually tangents 2 theta equals to 4 times root 2 over 2 is 2 times root 2. 2 times root 2. Okay, so we actually found out that tangents 2 theta equals to 2 times root 2. Okay, tangents 2 theta equals to 2 times root 2. But the problem is that in order to find out the radius of the small circle, we know that the radius of the small circle equals to AB times tangents theta. So we have to find out the value of AB, and we have to find out the value of tangents theta. Yes? But here we don't have tangents theta, but we have only tangents theta. we have tangent 2 theta. We want to find out the value of tangent theta, not the value of tangent 2 theta. Okay, so in order to find out the value of tangent theta from tangent 2 theta, we will use the following trigonometric identity that states that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. Okay, we will use this trigonometric identity in order to find out the value of tangents theta. So we know that tangents 2 theta equals to 2 times root 2, so we can write here, instead of tangents 2 theta, we can write that 2 times root 2, because tangents theta equals to 2 times root 2, equals to 2 times tangents theta over 1 minus tangents square theta. Okay, so here we can find out the value of tangents theta from this equality, but it will be much simpler to us to define that tangent theta will be equal to x, and then we will solve a quadratic equation, and in this way we will find out the value of tangent theta. Okay, so we will define that tangent theta equals to x. Okay, if tangent theta equals to x, in this equality we will substitute tangent theta by x. Okay, we will get that 2 tangent theta is 2x, because tangent theta equals to x, over 1 minus tangent theta equals to x, so tangent square theta will be equal to x squared. Okay, all equals to 2 times root 2. Okay, so here we actually substituted tangent theta by x, and we got this quadratic equation. So here we will cross multiply this expression, and we'll cross multiply this expression by 1 minus x squared. We'll get the 2x equals to 2 times root 2, 1 minus x squared. We will open the brackets, we will get the 2x equals to 2 times root 2 minus 2 times root 2 x squared. So here we will add to this equality 2 times root 2 squared, and we will get the 2 times root 2 square plus 2x equals to 2 times root 2. Here we will subtract 2 times root 2 from this equality, and we'll get that 2 times root 2 squared plus 2x minus 2 times root 2 equals to 0. Here we will divide this equality by 2, and we will get that root 2 times x squared plus 2x over 2 is x minus 2 times root 2 over 2 is root 2, all equals to 0. So we got a quadratic equation. Actually, if we have the general formula for a quadratic equation is a times x squared plus b times x plus c equals to 0 when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. And the solution of this quadratic equation is x, or x, the variable that we want to find out is x. X equals to minus b is the coefficients of this quadratic equation, plus minus root of b squared minus 4 times a times c over 2 times a. Okay, so that is the solution or solutions for the quadratic equation. Okay, and in our specific quadratic equation, the coefficients of our specific quadratic equation is a equals to root 2, b equals to 1, and c equals to minus root 2 minus root 2. Okay, so those are the coefficients of our specific quadratic equation, a, b, and c. So we will substitute a, b, and c in the general solution of the quadratic equation by our specific values for a, b, and c, and we will find out the value or the values of x. You should remember that x equals to tangent theta. Okay, so here we will get that x equals to b is 1, so minus b is minus 1, plus minus root of b square is 1 square, 1 square is 1, minus 4 times a is minus 4 times root 2, and c times c is times minus root 2. Okay, so here minus and minus will become plus, all divided by 2 times a, that is 2 times root 2. Okay, so here we got that x equals to minus 1 plus minus root of 1 root 2 times root 2 is 2, and 2 times 4 is 8, and minus is plus, so it is root of 1 plus 8 is 9. Okay, so we got that x equals to 1 plus minus root 9 over 2 times root 2. Okay, so x equals to 1 plus minus root of 9 is 3 over 2 times root 2. Okay, we will have here two solutions for x, because x equals to 1 plus minus 3 over 2 times root 2. So the first solution will be x equals to 1 plus 3 over 2 times root 2. It equals to 4 times root 2 4 times 4 over 2 times root 2, x equals to 4 over 2 times root 2, that equals to 4 over 2 is 2, so it is 2 over root 2. Here we will multiply by root 2 and then we will divide by root 2. We get root 2 times root 2. So here it equals to 2 times root 2 over 2 x actually equals to minus 1, so I wrote here 1 and it is actually minus 1 plus minus 3, so it is minus, instead of plus 1 it should be minus 1, so it is actually minus 1 plus 3 over 2 times root 2. Minus 1 plus 3 is 2, so actually x equals to minus 1 plus 3 over 2 over root 2. Okay, so that is the first solution for x. X equals to minus 2 plus 3 over 2 times root 2. So minus 1 plus 3 is 2. So we get that it equals to 2 over 2 times root 2. And 2 over 2 is 1, so it is 1 over root 2. So x equals to 1 over root 2. X equals to 1 over root 2. That is the first solution. And the second solution is that x equals to minus 1 minus 3 over 2 times root 2. That will be minus 4 over 2 times root 2, or minus 2 over root 2. It is actually negative number. It's less than 0, so, but we know that theta, we have a right triangle. Here we have a right triangle with theta, whatever. Theta is one of the angles of a right triangle. This is theta. This is 90 degrees. So theta is less than 90 degrees. Therefore, tangents is positive. Tangents is positive. Therefore, x that equals to tangent theta can never be negative number because of the fact that theta is less than 90 degrees. Then in this area tangents is positive, so we got a negative answer for tangents, for it is impossible, so it is incorrect answer, and the final answer is that x equals to, for tangent theta, x equals to 1 over root 2. Okay, x equals to 1 over 2 and x equals to tangent theta, so tangent theta equals to 1 over root 2. Okay, so that is actually half of the answer, because in the first time we found out that r is equal to AB times tangent theta. So we have already found out the value of tangent theta. Tangent theta equals to 1 over root 2, and the only thing that is left to find out, in order to find out the radius of the small circle, is to find out the value of AB. Okay, so we will find out the value of AB. This is actually AB. Okay, this line segment. After we will find out the value of AB, we will find out the value of the radius, because the radius equals to AB times tangent theta, and we already found out the value of tangent theta, and the only thing that is left to find out is to find out the value of AB. Okay, so first of all we will focus on triangle BOE. Okay, so in triangle BOE, this triangle, it is a right triangle. Tangents to theta equals to OE over BO. Again, in triangle BOE, the right triangle BOE, tangent theta equals to OE over BO. Okay, in the right triangle BOE, tangent to theta equals to OE over BO. But you should remember that we have already found out the value of tangents to theta. We found out that tangents to theta equals to 2 times root 2. We have already found out the tangents to theta equals to 2 times root 2, and we also know that tangent theta equals to 1 over root 2. So we know that tangents to theta, we have already found out that tangents to theta equals to 2 times root 2, So we can substitute tangent 2 theta by 2 times root 2. We'll get the 2 times root 2 equals to OE. The value of OE is the radius of the semicircle or the radius of the quarter, the same. The radius of the semicircle or the quarter is 3 units. So OE equals to 3 units over BO. Over BO. So from this equality we can find out the value of BO. BO will be equal to 3 over 2 times root 2. Okay, because here we will multiply this equality by BO and then we will divide it by 2 times root 2 and we will get that the value of BO is 3 over 2 times root 2. Okay, so in the next step we will join together points O and P by a straight line. Okay, actually OA is tangent to the small circle at point A, and we have a rule that a tangent always creates 90 degrees with the radius, so the tangent is perpendicular to the radius, so angle OAP must be equal to 90 degrees. Okay, according to the rule that the tangent is perpendicular to the radius. Because of the fact that the tangent is perpendicular to the radius, AP is the radius, so the angle between OA and AP is a right angle. This is a right angle. So actually, triangle APO is a right triangle. Triangle APO is a right triangle. Therefore, according to the Pythagorean theorem, the square of the hypotenuse in a right triangle equal to the sum of the squares of the perpendiculars. That is to say, AP square plus AO square equals to PO square. Okay, according to the Pythagorean theorem, in the right triangle APO, AP square plus AO square equals to PO square. Okay? Actually, here we will extend the side OP until it touches the semicircle at point M. Okay? Again, point M is the touching point between the semicircle and OM, okay? OM. Actually, as you can see from the drawing, MP is the radius of the small circle. We'll mark it as R. And MO is the radius of the big circle because of the fact that it exits from the center of the circle, that is to say point O, and ends at point M, that is a point on the semicircle itself. Therefore, MO is the radius of the semicircle. So the radius of the semicircle, capital R, minus the radius of the small circle equals to PO. Okay, again, PO equals to capital R minus R. Again, PO equals to capital R, the radius of the semicircle, minus the radius of the small circle. But we have already know that the radius of the big circle equals to 3 units. So we can substitute capital R by 3. So OP or PO equals to 3 minus R. Okay, PO equals to 3 minus R. And AP, actually, it is the radius of the small circle. So AP square is actually R square, or small r square, plus AO square. AO, I will leave it as it is, R square plus AO square equals to AP is the radius, so AP square is R square, and AO, I will leave it as it is, and PO, we've already found out that PO equals to 3 minus R, so PO square will be equal to 3 minus R square. Okay, so in total we got that R square plus AO square equals to 3 minus R square. We will open the brackets here. We will get that R square plus AO square equals to 3 minus R square is 9 plus R square minus 6R. So here we have R square in this side of the equality, and we have R square on the other side of the equality, so R square will get cancelled, and what is left after we cancelled R square is AO square equals to 9 minus 6 small r. Here we will take a root out of this equality, and we will get that the value of AO actually equals to the root of 9 minus 6R. Okay, we found out the value of AO. Okay, AO. But we know that AO minus BO equals to AB. Again, AB, as you can see from the drawing, that AB equals to AO minus BO. Okay, AB equals to AO minus BO. Again, AB equals to AO minus BO. You can see it from the drawing that AB equals to AO minus BO. Okay, AB equals to AO minus BO. But we have already found out that AO equals to the root of 9 minus 6R. And we have already found out that BO equals to 3 over 2 times root 2. BO equals to 3 over 2 times root 2. Okay? So we have the value of AO, we have the value of BO, therefore we also have the value of AB. So here AB equals to AO minus BO, or AB equals to AO is the root of 9 minus 6R, and minus BO is 3 over 2 times root 2. Okay, so we actually found out the value of AB. We found out the value of AB. AB equals to the root of 9 minus 6R minus 3 over 2 times root 2. And we also found out that the value of tangent theta is 1 over root 2. Okay, the value of tangent theta is 1 over root 2. And we know that the radius of the small circle equals to AB times tangent theta. The radius of the small circle equals to AB times tangent theta. We know that AB equals to the root of 9 minus 6R minus 3 over 2 times 2. And we know that tangent theta equals to 1 over root 2. So we have to multiply the value of AB by the value of tangent theta in order to find out the radius of the small circle. Okay, so we'll substitute AB by this expression, and we will substitute tangent theta by 1 over root 2, and we will find out the radius of the small circle. Okay, so we will do it now. So the radius, small r, of the small circle equals to AB. AB is the root of 9 minus 6R minus 3 over 2 times root 2. This is AB times tangent theta, and tangent theta is 1 over root 2. Okay, so after we substituted AB by this expression and tangent theta by 1 over root 2, we got this equality, and here we will multiply this equality by root 2. we will get that root 2 times r equals to root of 9 minus 6r minus 3 over 2 times root 2. So here in this equality we will add to this equality 3 over 2 times root 2, and we will get that root 2 times r plus 3 over 2 times root 2 equals to the root of 9 minus 6r. Okay, so we got this equality. Here we will multiply this expression by 2 times root 2, and then we will divide it by 2 times root 2 in order to have a common factor in this expression. We will get that 2 times r 2 times root 2 over 2 times root 2 plus 3 equals to root of 9 minus 6r. We multiplied this expression by 2 times root 2, and then we divide it by 2 times root 2. So here we have 2 times root 2 times root 2 is 2, and 2 times 2 is 4. So in total we will have here 4r plus 3 in the numerator. Okay, in the numerator we have 4r plus 3 over 2 times root 2 equals to root 9 minus 6r. Here we will square this equality in both sides. Again, we will square this equality in both sides. We will get that 4r plus 3 square over 2 times root 2 square. 2 square is 4, and root 2 square is 2, so 4 times 2 is 8. And here we have root and square, so the root is cancelled by square, and in total what is left in the other side of the equality? 9 minus 6r. Okay, so after we squared this equality, we got that 4r plus 3 square over 8 equals to 9 minus 6r. Here we will multiply this equality by 8. We will get that 8 times 9 is 72. 8 times minus 6 is minus 48r equals to, we will open these brackets. It is 4r plus 3 square is 16r square plus 3 square is 9 plus 2 times ab. 4r times 3 is 12r. 12r by times 2 is 24r. So in total we got that 16r squared plus 9 plus 24r equals to 72 minus 48r. So here we will add 48r to this equality. 48 plus 24 is 72. So in total we will get that 16r squared plus 72r plus 9 equals to 72. Here we will subtract 72 from this equality and we will get that 16r squared plus 72r. 9 minus 72 is minus 63, all equals to 0. So we got a quadratic equation. In this quadratic equation, a equals to 16, b equals to 72, and c equals to minus 63. Okay? And again we have the general solution for a quadratic equation, that is x squared equals to minus b plus minus root of b squared minus 4 times ac over 2 times a. Okay? Again, that is the general solution for any quadratic equation. Actually, in our specific quadratic equation, the variable is r. So we'll substitute x by r. So r will be equal to, b is 72, so minus b is minus 72, plus minus root of 72 squared minus 4 times 16 is minus 64 times minus 63 over 2a. A is 16, so 2a is 32. So we got this equality. Actually 72 square is 5,184. And 63 times 64 is 4,032. So in total we got this equality, and and 5,184 plus 4,032 equals to 9,216. and the root of the root of 9216 is actually 96. So in total we got here two solutions. R equals to minus 72 plus minus 96 over 32. So the first solution will be R equals to minus 72 plus 96 over 32. 96 minus 72 is 24. 24 over 38 is 3/4, or 3 over 4, or 0.75 units, okay? So the first solution is that the radius of the small circle equals to 0.75 units, or 3 over 4 units. And the second solution to the problem is that R equals to minus 72 minus 96 over 32. It is actually minus 168 over 32. It equals to minus 5.25. Okay, so the radius according to this solution is minus 5.25, but because of the fact that the radius of any radius must be a positive number, this solution is not correct, and we left only with the solution, so it is not correct, and we left only with the solution that the radius of the small circle equals to 0.75 units, or 3 over 4 units. Again, the radius of this small circle equals to 0.75 units, or 3 over 4 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of the small circle, this small circle, and we know that the small circle is inside a quarter circle, this quarter circle, and we know also that angle DCE equals to 90 degrees, chord CD equals to 2 units, and DO equals to 3 units, and we want to find out the radius of this small circle. Okay. So first of all, we defined the center of the small circle as point P. Then we join together by a straight line points A and P, and we also join together by a straight line points P and X, and we also join together by a straight line points P and B. Okay, and we defined angle ABP is theta. This angle is theta, and we know that tangent theta equals to AP over AB, and AP is the radius, so in total we will get that the radius of this small circle, small r, equals to AB times tangent theta. So in order to find out the radius of this small circle, we must find out the value of AB and also the value of tangent theta. Okay? Again, we know that tangent theta equals to AP over AB, and AP equals to R, so R equals to AB times tangent theta. So in order to find out the radius, we must find out the value of AB, and also we must find out the value of tangent theta. Okay, then we actually proved that triangles APB and PBX are congruent to each other, and from the fact that those two triangles are congruent to each other, we can derive that angle ABP equals to angle PBX equals to theta. So we can derive that this angle is also angle theta, and actually angle CDE equals to 90 degrees, but angle CDE, angle DCE, this angle equals to 90 degrees. This angle, angle DCE, is a peripheral angle, and we have a rule that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. Okay, so therefore DE is the diameter of the circle. We know that this angle is 90 degrees because it is a quarter circle, and we know that the sum of the angles on a straight line is equal to 180 degrees, and this angle is 90 degrees, so this angle must be also 90 degrees in order to complete the sum of the angles on the straight line DE to 180 degrees. So this is a straight line. Okay, and therefore this angle BOE equals to 90 degrees. Then actually, because of the fact that those two angles are equal to theta, so theta plus theta is 2 theta, so this angle and this angle are two vertex angles, therefore the vertex angles are equal to each other, therefore this angle is also 2 theta, and therefore this angle is 90 degrees minus 2 theta. And then we know that the sum of the angles in any triangle equals to 180 degrees. So 90 degrees plus 90 degrees minus theta plus the size of this angle must be equal to 180 degrees. So by solving this equality, we found out that angle EDC equals to 2 theta. And Then we focused on triangle CDE, the big triangle. We noted that it is a right triangle, and we can implement the Pythagorean theorem that states that CD square plus CE square equals to DE square. Okay. CD square plus CE square equals to DE square. And we found out that again in triangle CDE, CD square plus CE square equals to DE square. CD equals to 2, so CD square is 4. CE square equals to ED square. ED equals to 3 plus 3 is 6. So 3 plus 3 square is 6 square. And so DE equals, it is the diameter of the semicircle, so it actually equals to R plus R, that is 3 plus 3 is 6. So we know that DE square equals to 36. Okay? And CD equals to 2 units. So the only missing variable that we have here is CE. So by solving this equality, we found out that CE equals to 4 times root 2, and we have already found out that tangent 2 theta equals to 2 times root 2. So again, we know that tangent theta equals to 2 times root 2, and the radius of the small circle equals to AB tangent theta. After we know that tangent 2 theta equals to 1 over root 2, it is not enough because we must find out the value of tangent theta and not 2 tangent 2 theta. Okay. So tangent 2 theta, according to this trigonometric identity, equals to 2 times tangent theta over 1 over minus tangent theta square. Okay. So we have this trigonometric identity. We used this trigonometric identity in order to find out the value of tangent theta. Then we defined tangent theta as x. So we have to solve a quadratic equation, and after we solve the quadratic equation, we had two solutions, and the only solution that is left is x equals to minus 1 plus 3 over 2 times 2. So we found out that tangent theta equals to 1 over root 2. Okay, so we found out that tangent theta equals to, from the trigonometric identity from tangent 2 theta, the tangent 2 theta equals to 2 tangent theta over 2 tangent theta over 1 minus tangent square theta. We found out that tangent theta equals to 1 over root 2. Okay? We found out that tangent theta equals to 1 over root 2, and we have the equality that R equals to AB times tangent theta. So after we found out the value of tangent theta, the only thing that is missing is the value of AB. So we found the value of AB by in triangle BOE. This triangle, we know that tangent 2 theta equals to OE over OB. Tangent 2 theta equals to OE over OB or BO. But we have already found out that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta in this equality by 2 times root 2. Okay, and after we substituted tangent theta by 2 times root 2, we got that BO equals to 3 over 2 times root 2. Okay, and we know that in triangle APO, this small triangle, that the tangent OA, the tangent is always perpendicular to the radius, so AP is the radius and OA is the tangent, so the tangent must be perpendicular to the radius, so angle PAO must be equal to 90 degrees. Okay, and we implemented, so triangle APO is a right triangle, so we can implement the Pythagorean theorem in the right triangle. That is to say, AP squared plus POS squared equals to PO squared. AP squared plus PO squared equals to PO squared. And we extended OP until it touches the circle at point M. Actually, OP or PO equals to the radius of the semicircle minus the radius of the small circle. Okay, so PO equals to R minus R, and capital R equals to 3, so OP equals to 3 minus R, small r. And again, in the right triangle APO, we implemented the Pythagorean theorem. That is to say, AP squared plus OS squared equals to PO squared. Okay, or R squared plus OS squared equals to PO squared. PO is 3 minus R, so PO squared is 3 minus R squared. And after we solved this equality, we found out that BO equals to 3 over 2 times root 2. So BO equals to 3 over 2 times root 2. Okay. And what is the value of AB? AB equals to OA minus BO. AB equals to OA minus BO. So AB equals to OA is root 9 minus 6R, and BO is 3 over 2 times root 2. And tangent theta is 1 over root 2, so the only thing that is left to do here is to substitute AB by its expression and to substitute tangent theta by 1 over root 2. Okay, so we did this. Okay, and we found out, we actually got to a quadratic equation, and by solving this quadratic equation we found out that the radius of this small circle is either equals to 0.75 units, or it is a negative number, but because of the fact that the radius of any circle cannot be a negative, so that is the only solution that is left, that the radius of the semicircle equals to 0.75 units, or 3 over 4 units. Okay, so the radius of this small circle equals to 0.75 units, or 3 over 4 units. Okay, thank you very much.